this is a Bhagavatam class, so I was asked to say a few words about Vedic cosmology and the structure of the universe. Just as a preface to that, in 1976, Srila Prabhupada wrote a letter in which he said, "Now all our PhDs must collaborate and study the 5th canto to make a model for building the Vedic planetarium." And he makes a number of comments there, and he says, "Now all the PhDs must carefully study the details of the 5th canto and make a working model of the universe. If we can explain the passing of seasons, eclipses, phases of the moon, passing of day and night, etc., then it will be a very powerful propaganda." So that's what Srila Prabhupada said back in 1976. This was written to Bhakti Swarup Damodar Maharaj. So, of course, now it's 1986. But this 5th canto of the Srimad Bhagavatam has always been a cause of perplexity to many devotees and other people who have read it. This section of the Bhagavatam describes the layout of the universe, and it describes it in terms that are quite unfamiliar to a person with standard Western upbringing and background. So what I was going to do in these talks was to provide some explanation to clarify what the 5th canto is actually saying. So if you look at briefly at the 5th canto, you'll see that it is describing the earth, or what is translated there as the earth, in somewhat unusual terms. The word there used for the earth is Bhumandala. So Bhu means earth, and Mandala is a Sanskrit word that basically means something round. It could be a circle or a ball or something like that. Actually, the word mandala has come into English via Tibetan Buddhism and things like that. A round figure with various designs in it is called a mandala. So the earth is referred to as Bhumandala, and one can understand from the text that this essentially is a reference to a disk, something shaped like a disk. And the radius of this disk is about, the diameter is given as 50 koti yojanas. This is a figure you get accustomed to. Panchasat koti yojanas. Koti is 10 million. So that would be 500 million yojanas. And in the Bhagavatam, Srila Prabhupada uses the figure of 8 miles for a yojana. So 500 million times 8 miles gives you 4 billion miles. So imagine a disk 4 billion miles in diameter. So that is what is referred to in the 5th canto as the earth. So naturally this is somewhat bewildering to people. So in the modern day and age, we're accustomed to thinking, first of all, that the earth is a globe, it's a sphere, and we're certainly not accustomed to thinking that it's as big as 4 billion miles in any of its dimensions. According to modern understanding, the earth is about 25,000 miles around the equator. So that's the greatest distance you can travel on the earth without coming back to your starting point. So 25,000 miles, that's fairly small distance. You can say it's roughly about 8,000 miles in diameter. So if pi is about 3 times 8 is about 24. So you can see 25,000 miles in circumference and about 8,000 miles in diameter. So that is tiny compared to a disk which is 4 billion miles in diameter. So this is the basic problem. Now, we have a lot of experience in our modern society which tends to suggest that the Earth really is a globe. For example, we have travel by jet airplanes, and devotees, at least quite a number of them, tend to be bona fide members of the jet set. Some of them even get free tickets from different airlines because they travel so much. So we have experience of traveling from city to city around the Earth. We experience time zones. There's jet lag. You can go to India, and what is it, about a 12-hour time shift? Or going from here to Los Angeles, there's a 3-hour time shift, and so on. So all of these things make sense in terms of the idea that the Earth is a globe. And of course, if you look at the routes that you follow, if you travel, say, from London to New York and see where the plane is going, you'll see that you come to land in North America first up in Labrador, someplace like that, and you come down over Massachusetts, you fly over Boston, and eventually you get to New York. So if you look at an ordinary Mercator projection map, it seems that you're going in a big arc to the north and then coming south. But if you look at a globe, you'll see that the shortest line between London and New York, in fact, goes over Labrador and northern New England and so forth. So we have all this experience that indicates that the Earth is a globe. So then how can it be that the fifth canto is describing the Earth as a disk 4 billion miles in diameter? So what's really going on here? This is the real question that comes up with the fifth canto, and in connection with that, there are many other questions that go along with it. But in a way, this is the basic question. So, first point to note then is that this apparent conflict in understanding the fifth canto is not something new. And it is not a conflict between Vedic literature and modern scientific understanding. Actually, there's a whole body of Vedic literature which describes the Earth as a small globe. And this literature is what Srila Prabhupada in his purports refers to as Jyotir Veda, or Jyotisha Shastra. So there's a whole body of literature like this. So, just to indicate, and also, as I was finding out recently, commentators on the Bhagavatam, including the commentators that Srila Prabhupada referred to in writing his purports, have explicitly discussed this issue. So I'll give you a quote. This is something which was recently translated by Shukavak and myself. We were going over some of these commentaries. This was written in Sanskrit by someone named Vamsidhara. And we don't yet know who exactly Vamsidhara was, that is, how he relates to various other figures that we know. His commentary appears right after Sridhar Swami's commentary in the Bhagavatam. But he makes the following interesting statement. He says, Sri Vyasadeva, for the purpose of confusing the Asura Janas, created apparent contradictions in the Jyotir Shastra, but there's no contradiction in reality. Otherwise, he would be obscuring the Vedas. This is the correct understanding. How then can the contradictions be resolved between the 100,000 yojana size of Jambudvip in the Puranas and the 5,000 yojana size of the Earth globe in the Jyotir Shastras? The Earth has two forms. One is a very big, specific form, Vishesha, given in the Puranas, and the other, according to Jyotir Shastra, is a small globe. And then he goes on to describe this in more detail. So, and he goes on to explain what's going on here. So, just to briefly explain further, I mentioned that the Earth is 4 billion miles in diameter, according to the Srimad Bhagavatam, the 5th canto, and it is divided into different parts. One of those parts is Jambudvip, and that is described as being 100,000 yojanas across, which would be 800,000 miles. That's about the size of the sun, according to modern ideas of the sun. So this Jambudvip is normally identified with the region of the Earth in which we're living, but I'll be discussing that more later on. So Vamsidhar here is mentioning Jambudvip, which is 100,000 yojanas across, and he mentions the Earth, which he gives a figure of 5,000 yojanas. Well, as a matter of fact, as I'll describe later, the yojana has a somewhat variable measure. He is using yojanas that are 5 miles to the yojana, and there's other evidence indicating that this is the case. And if you multiply 5 by 5,000, you get 25,000. In other words, he's saying the Earth is 25,000 miles in circumference. So he's talking about the same Earth globe that we're talking about. So it's worth knowing that the traditional commentators on the Bhagavatam also knew about the idea that the Earth is a globe about 25,000 miles around. It's not that they were unaware of this idea. In fact, this is described in what is called this Jyotisha Shastra. So, I'll say a little bit more about Jyotisha Shastra. First point is to cite a purport in the Chaitanya Charitamrita given by Srila Prabhupada. This is a purport to a verse which describes some of the time units that are used in Vedic calculations. But in the purport, Srila Prabhupada says, these calculations are given in the authentic astronomy book known as the Surya Siddhanta. This book was compiled by the great professor of astronomy and mathematics, Vimal Prasad Datta, later known as Bhaktisiddhanta Saraswati Goswami, who is our merciful spiritual master. He was honored with the title Siddhanta Saraswati for writing Surya Siddhanta, and the title Goswami Maharaj was added when he accepted sannyas, the renounced order of life. So, here Srila Prabhupada refers to a book known as Surya Siddhanta. Now, this is one of the books in this Jyotish literature. And indeed, it turns out that Bhaktisiddhanta Saraswati was an expert in this field of the Vedic Shastra. Just to give an indication of this, we have some information here concerning Bhaktisiddhanta. It's described that in 1897, Bhaktisiddhanta opened a toll or school named Saraswata Chatushpati in Calcutta, and it said here, this is for teaching Hindu astronomy nicely calculated independently of Greek and other European astronomical findings and calculations. And at this time, he also published 2 magazines on this subject, one called Jyotir Vid and the other was called Brihaspati. And, in addition to that, he has a whole list of publications on Vedic astronomy. There's quite a long list here. For example, he translated Bhaskaracharya's Siddhanta Shiromani and a whole series of things with very long Sanskrit names here. Quite a list of things. So Bhaktisiddhanta was very much involved at one time with this Jyotish Shastra. Indicate that these literatures are definitely a part of the Vedic tradition and a part of our own line of disciplic succession. So, what I thought I would do here is give a brief description of how the Surya Siddhanta describes the universe. And this will be useful not only for discussing the Jyotish Shastra, but it will allow me to introduce some sort of practical, fundamental knowledge of astronomy because although in the modern day and age there's a highly developed science of astronomy, and one hears of the Mount Palomar telescope and so on, most modern city dwellers never even look at the sky. The most they know about astronomy is that the sun rises in the east and sets in the west, and you see stars at night, at least if you go out in the country. But that's about as far as it goes. So I thought I'd indicate some ideas, first of all, about what one sees. By the way, I forgot to bring a watch. Maybe I can be warned of the passage of time in case I go on too long here. Oh, that's good. How long should this go? For about, what do you think?
Well, maybe you can talk for an hour.
Okay. I can cover a certain amount of material. Yeah? Yes, that's one project. We want to do that. Oh, yeah. One big project that we have now is to find those writings, also to translate the commentaries of various commentaries on the Bhagavatam, because in fact there's a lot of material there on astronomy. So that is definitely something that has to be done. So let me first say a few words about what one sees in the sky if one looks. Of course, we know the sun rises and sets. So let me first define a standard orientation. That is, you're standing looking to the south. In fact, the best idea is that you're standing in India looking to the south. All the descriptions of what is going on in the sky that you find in the Vedic literature, as far as I can see, sort of take it for granted that this is your orientation. So, with this orientation, the sun rises to your left and goes up into the sky in an arc, moving to the right, and then sets to your right. So this is pradakshina kurvan is the word they use, motion to the right. So, and you can also think of it as clockwise. If you hold a clock like this, then the hands go around in the same way the sun is going. So, it's described that this is one basic motion of the sun, clockwise or motion to the right, which is on a daily basis. It takes one day to go around. So, of course, during the daytime you can't see stars, but if you look at the stars at night and the moon and so on, you'll see that they're also moving in the same way. They rise in the east and move around to the right and set in the west. And if you look towards the north, you'll find that there are some stars that never actually set. They go around in a circle in the sky, and as you keep going to the north, the circles get smaller and smaller. Well, facing the south, north is over your shoulder. It's to your back, so you have to turn around. Of course, I'm facing north right now. So you have everyone here is actually facing south, so you can apply these statements to yourself. But in that direction, up at a certain angle in the sky, you'll see the circles in which the stars are moving on a daily basis shrink down to a certain point occupied by a star we call the pole star. So the pole star tends to remain stationary, and all the stars seem to be circling around it in circles. And as the circles get bigger, finally they intersect the horizon of the Earth, and then as you go on, the stars seem to rise, go around in a circle, and set. And this takes place in a period of one day, that is one complete circle. Now, it turns out, though, that the stars rise and set at a faster rate than the sun does. So there are two kinds of days, which you could call what's called a sidereal day and a solar day. So a sidereal day, you can call that a star day. It's the time from the time a given star rises to the time it rises again. Whereas a solar day is the time from when the sun rises to when it rises again. So the stars go slightly faster than the sun. So sidereal day is slightly shorter. So the way you can visualize this is to think of something called the celestial sphere. And maybe I'll make a drawing here to indicate that. So what I've done here, this small sphere that you see represents the Earth. And the large sphere around it represents just a big imaginary sphere drawn centered on the Earth. So the Earth's equator is indicated in its axis. And then on the big sphere, there's also an equator that matches the Earth's equator. That is, it's just extended out on straight lines from the center. So this big sphere is called the celestial sphere. So if you're standing on the Earth, you can imagine all the different bodies that you see up in the heavens to be projected as little dots on the surface of this sphere. So the first point is, if you think of the stars projected on this sphere, it's as though the whole sphere is rotating around this fixed axis. So the pole star is actually right where the axis passes through the sphere, up to the north at the top. So as the sphere rotates, the pole star doesn't move. And everything else moves in a circle. There are circles of varying sizes. And you can see that if you're on the surface of the Earth in, say, the northern hemisphere, you'll be able to see some complete circles, but the Earth will block your vision for some of the other circles, and so they won't be complete. So that's how the stars move, once per sidereal day. So the next question, the next thing to bring up then is the motion of the sun. So if we forget about if we just pay attention to the stars fixed on this sphere, we then see that the sun is moving relative to the background of stars. So, of course, during the day you can't see the stars that are near the sun because it's so bright. But if you could see that, you would see that on one day the sun was in front of a certain constellation. And as the days went by, the sun would gradually drift across the sky, and it would pass from one constellation to another. And it would gradually go in a big circle all the way around this celestial sphere and come back to its starting point again. And it takes 1 year to do that. And the motion of the sun against the background of the stars is to the left. It's the opposite of the motion of the sun on its daily cycle. So, as I say then, the way to visualize this is to imagine that you could look at the sky and see the stars as well as the sun. And imagine at a certain time of day, every day you looked. Well, with each successive day, the sun would be moving slightly in the leftward direction. Yeah, you're always looking at the same time. Say at noon, every day you look at the sun, and you can see and this is sidereal noon. The important point about it being sidereal noon is the stars will be in the same position at this time every day. So, if you look at the sun every day and watch what it's doing, you'll see it's moving leftward across the sky. Eventually it will set in the east, and then it will rise in the west and move around, and in this way be moving counterclockwise. So this is the yearly motion of the sun. It takes 1 year to make a complete circle. And the sun follows a particular path against the background of stars. And there are various names for this. First of all, there are constellations in the sky that are called basically the zodiac. Everyone's probably heard of the zodiac. The sun follows a particular path which is called the ecliptic. I'll make a drawing of what that is. This is a very crude drawing. But what I've done is draw another circle. It's called a great circle in the celestial sphere. And you notice it's at an angle to the equator, the celestial equator. The angle is actually about 23 degrees. So what happens is, over the course of the year, the sun is moving on this circle counterclockwise. And you see the circle is at a tilt to the equator. So sometimes the sun is moving in a somewhat northerly direction as it goes around this circle until it comes to the highest point, and then it's moving in a southerly direction until it comes to the lowest point, and then it goes back up north again. So when it reaches the most northern point, that's called the summer solstice, and that was just a few days ago. That's the point at which the sun comes furthest to the north. Now, if you think about the daily motion of the sun, when the sun comes furthest to the north, that means the whole arc that the sun travels during one day is shifted the most towards the north. So that occurs during the summertime. And as that occurs, the days get longer and longer until when the sun is at the northernmost point on this ecliptic path, the length of the daytime period is longest and the nights are shortest. So then as the sun continues around on the ecliptic, it reaches a point where the ecliptic intersects the celestial equator. At that point, the length of the day and the length of the night are equal. So that's called the equinox. Then it keeps on going as you go into winter time until it reaches the southernmost point. So at that point, the sun is furthest to the south and the day is shortest. And that's called the winter solstice. That's around in December. And then it comes back up to another equinox and up to the solstice again. So, pardon me? Right. Yeah, there was a pagan holiday at that time. So they shifted the celebration of Christ's birth to that time. So anyway, that is how the sun basically moves. So it is described then that there are two motions to the sun. This rightward daily motion and the leftward yearly motion. And the rightward daily motion tends to go on one plane of rotation, corresponding to the equator here, and the yearly motion is on another plane tilted at 23 degrees to that plane. So that's the basic thing that one sees in the sky. And then I should mention the planets. So in the Vedic literature, there are 9 planets that are normally spoken of. These are, and this is somewhat different from the enumeration of planets in the modern conception. So the 9 planets are the Sun, the Moon, and then Mercury, Venus, Mars, Jupiter, and Saturn, and Rahu and Ketu. Those are the 9 planets in the Vedic system. So the Sun and the Moon are also called planets. So I've been describing how the Sun moves. Now the perspective in the Vedic literature is what is called geocentric. That is, one takes the Earth as being a fixed reference point, and one considers how everything is moving relative to the Earth. So, according to this idea, the Sun is orbiting around the Earth, and so is everything else. The Earth is fixed in one position. So, we've been discussing then the orbit of the Sun. All the orbits of the different planets can be plotted against the celestial sphere. Every planet has its daily east-west motion, just as the sun does. Everyone can see this in the case of the moon. You'll see that the moon also rises in the east and sets in the west. So each planet similarly rises in the east and sets in the west. But each planet has its own motion against the background of the stars. So to think of the motion of the planet, the easiest thing to do is think of its motion against this celestial sphere, against the background of stars. So we've already described the orbit of the sun, and that's this circle I've drawn, which is called the ecliptic. So one can also consider the orbit of the moon. Now, it's easy for us to see what the moon is doing against the background of stars because the moon isn't so bright, so you can actually watch it from day to day. But if you do that, you'll see that with each successive evening, say if you look at the moon at the same time, it is shifted quite a ways to the east. So this is easy to see. Or in the morning, you'll see one morning, actually a few mornings ago, the moon was full at about time for Mangalarti. And then the next day, if you looked at the same time, it was not quite so full, and it was quite a ways up in the sky. When it was full, it was on the horizon, just about time for Mangalarti. And a bit later, it was well up in the sky, moving towards the east. And right now, it's a thin sliver, and it's about to set in the west at that time. So the moon also has a motion to the left, moving towards the west. But its motion is about 12 times as fast as the sun's motion. However, it follows nearly the same path as the sun, but not quite the same. It stays very close to this path called the ecliptic. And it has its own motion, going around once in a month instead of once in a year. And the same thing is true of the other planets, such as Mercury, Venus, Mars, and so forth. They all have their motions going towards the east, or going to the left. And different planets have different motions. So the motion of the sun and the moon is fairly simple to draw. It goes just in a circle. I've drawn the circle for the sun, and for the moon it's a similar thing. Now for the other planets, the motion is more complicated. And I'll just give you an indication of what it looks like. This diagram indicates basically what the motion of the planets looks like. Now mind you, I'm presenting all this as a preface so that we can understand the Vedic outlook on the universe. It's quite important to understand what you actually see in the sky. People today are taught that the various planets orbit around the sun in elliptical orbits and so on. But at least not very many people think of what this means in terms of what you actually see. Well, since the Vedic literature is describing what you see out there, amongst other things, it's important to know what that is. So this is the kind of motion a typical planet follows. I've drawn a line that loops back on itself. So typically what a planet will do is, against the background of stars, it moves towards the left along the ecliptic, close to it but not exactly on it. And it will move for a while, then it will reverse and go back towards the right again. That's called retrograde motion. And then again it will move to the left, and then again reverse and go to the right, and then again to the left, and so on. So the overall motion is to the left, but it keeps doubling back on itself. So that's what the planets do. That's their characteristic motion. So that's the introduction. Here I've exaggerated how far it goes from the ecliptic. It really stays very close to it. These backward loops are very flat. So the Surya Siddhanta, which was translated into Bengali by Bhaktisiddhanta Saraswati, describes all of these orbits mathematically. Actually, you can think of the Surya Siddhanta as a computer program for calculating exactly how these planets move through the sky. In fact, of course, it was written for people who didn't have computers and who just would calculate by themselves. But it's written as a program. If you read the Surya Siddhanta, you'll find it says, write down this number, multiply it by that, add it to this other thing, look up this in a table, and multiply, and so on. And it just goes on like that. So, but what it does is it presents calculations so that if you know, first of all, the time, then you can calculate where each planet is on the celestial sphere. You can measure position on the celestial sphere by putting coordinates of latitude and longitude there, just as you do on the Earth. You know, you have a grid of latitude and longitude coordinates on the Earth. Well, similarly, you can put that on this bigger globe, and thus you can give a position to every planet. So you can calculate those positions using the Surya Siddhanta. And in fact, it's interesting. You have to know the time from the beginning of Kali Yuga. So, in fact, it's measured in days and fractions of a day. So if you know the time in days and fractions of a day from the beginning point of Kali Yuga, you can use that to calculate where each planet is going to be on the celestial sphere at that moment. And conversely, if you know where the planets are at a given time, you can ask, well, at what time would the Surya Siddhanta give the planets in those positions? That must be the time we're at in Kali Yuga. And that's why we say Kali Yuga begins 5,000 years ago. Because in fact, the precise time is about, well, roughly speaking, it's about 5,000 years from the beginning of Kali Yuga till now. So that's based on this Jyotisha literature. Yeah?
When you said where the planets on people when it's birthday, what strategy do you have to science and astrology where according to time you can calculate what planet is going to be where to go?
Well, in fact, these calculations are used by astrologers. You see, a modern day astrologer will use something called an ephemeris, which is published by some convenient organization that we don't worry about. And in the ephemeris, you just look up the positions of the planets as a function of time. But the Surya Siddhanta enables you to actually calculate the positions of the planets. And of course, they did use this to make tables so that you could look up positions as a function of time. So that's what the Surya Siddhanta does. I could mention some things about the Surya Siddhanta. It is actually quite accurate. It works in describing these things. And it is based on what is called a system of epicycles. So I'll describe briefly what that is, just so as to relate this to the modern conception. Now, everyone in the present day and age is raised according to the idea that the planets are orbiting around the sun. So I'll make a diagram of indicating what that looks like. In this diagram, the sun is at the center here. We'll call this S, V, and E. We have the sun at the center, and then in a circle here we have Venus. So the idea is that Venus is orbiting around the sun in a circle, and at a larger circle we have the Earth. And the idea is that the Earth is orbiting around the sun. Well, in the Surya Siddhanta, you have the following picture. You'll notice what I've done there is I've drawn the Earth, the Sun, and Venus in the same position. I've drawn a different set of circles. So in the one case, the Sun is at the center, and the Venus and the Earth are moving around in a circle. In the other case, the Earth is at the center, the Sun is moving around the Earth in a very large circle, which is only partially drawn here, and Venus is moving around the Sun in a smaller circle. It actually should be the same size as the one in the first drawing. So if you think about it, you can see that from the point of view of somebody standing on the Earth, both of these pictures give you the same motion in the sky. It's just a matter of what you want to take as the center of rotation. But from an observational point of view, they're equivalent. So the Surya Siddhanta uses this picture. However, the dimensions of these orbits are the same. That is, in the Surya Siddhanta, the size of the Earth's orbit and the size of the orbit for Venus are the same size. Except, of course, I say Earth's orbit, it's the Sun's orbit in the case of the Surya Siddhanta, because it's the Sun that is moving, whereas it's the Earth's orbit in the case of the modern heliocentric system. So that's the relation, essentially, in simple terms, between the Surya Siddhanta and the modern system. And I should relate these pictures to the ecliptic plane or circle that I was drawing before. Of course, these pictures lay flat in the plane of the blackboard. But actually, in space, either way you look at it, you have these things moving essentially in a plane, in a particular plane in space. Well, in fact, that corresponds to the ecliptic that I was drawing before. So looked at from a heliocentric point of view, the plane of the ecliptic corresponds to the plane of the solar system, which is essentially flat. Or looked at from a geocentric point of view, well, you can call it the Earth-centered system, in which the sun is going around and the planets and so on are all going around the Earth, essentially in the same plane, or very close to it. So that's the basic picture given in the Surya Siddhanta. Now, there are quite a number of things one can say about the Surya Siddhanta. I'll just say a couple more things to wind up this lecture, and the next lecture we'll begin discussing what the Bhagavatam says, and then we'll see how these things relate to one another. This is background so that one can understand essentially what the Bhagavatam is saying. So, the final thing that I thought I would point out is that from a modern point of view, one might think that the Surya Siddhanta is a somewhat outmoded system, rather quaint and archaic. But I would suggest that there are indications of considerable sophistication in this description of the solar system, and here's one indication of that. In the Surya Siddhanta, there is a table giving the diameters of the planets. This is a rather intriguing thing. The diameters are given as projected to the orbit of the moon. Now, what that means, I should explain that. Imagine that someone is holding up a basketball at a distance, and at arm's length someone holds up, say, a penny, and the penny perfectly matches the size of the basketball from his point of view. So that means that at arm's length, the basketball size projected to arm's length for that observer is the size of a penny. This is what I mean by projection. So, obviously, if a thing is of a certain size, if it's far enough away, it will project down to any given size. So, similarly, if you imagine a planet as a big globe out there in space, now project it down to the orbit of the moon. How big would it be when projected to the orbit of the moon? So the Surya Siddhanta gives a series of numbers for how big all the different planets are projected to the orbit of the moon. And these numbers vary as a function of time, by the way, because the distances of the planets vary as time passes. So, using these figures, and figures for the distances of the planets, you can calculate backwards and obtain figures for the actual diameter, the right numbers for the diameters of the planets. Except in two cases, you're off by a factor of 2, which to me suggests that radii are being given instead of diameters somehow. There's some mistake in the text. But taking that into account, the numbers you get come within 10% or even less of the present values for the diameters of the planets. And this is a rather interesting thing, because you might ask, how could people measure the diameters of the planets? Nowadays, the way it's done is you have to use a telescope, because if you look at a planet, for example, many of you may have seen Venus, which is sometimes called the morning star. It's quite bright in the morning, but it looks like a star. And I think one would have to have very good eyesight to even see that as a disk. And then to measure that disk is another thing. So, it's hard to see how anyone could do it. But yet the right figures are there. So how did they know? After all, according to our modern history, the telescope was invented by Galileo, or at least first used for astronomy by Galileo back in 1600 something. And that probably wasn't, his instrument wasn't even adequate to determine these diameters. You'd need more powerful telescopes. So people even in the Middle Ages in India presumably could not calculate such things. Yet the information is there. So that's just an indication that there's something going on here. Some people actually knew something in the past there in India. So I'll stop there for this evening. Anybody like to ask questions about the material so far? Yeah? What I was about projection down to the orbit of the moon? Well, that's not the method of parallax. It's just a simple proportion. You know, if something at a given distance x has a certain size, then if you move it to 2x, it seems half as big. And if you move it to 3x, it seems a third as big, and so on. It's just a matter of proportion. Yeah? They have equations, yeah. That's known as Newtonian astronomy. So there's the Newtonian system, which provides equations for calculating how the planets move. The solar time. Yeah. That's a different thing called precession of the equinox. Yeah, that's another topic. But the point of the equinox where it intersects where the ecliptic intersects the celestial equator, that shifts. But that's another whole subject. It's different from it doesn't have anything to do with the difference between a sidereal day and a solar day. The equinox? Well, once again, that's a whole subject, but that is measured. It's been observed over the last so many hundred years. But we'll discuss that also in more detail. Yeah?
First thing you said, you read that statement of Bamsidar. You said one of the effects of the Occidente was trying to bewilder the people.
Yeah, he said Vyasadeva put some apparent contradictions there to bewilder the Asura Janas. One could take it that way. But anyway, that's what Vamsidar said. But he said the contradiction is not real. It just seems to be a contradiction. So we'll discuss how that could be. You had a question? Mm-hmm. Mm-hmm. Well, there are always questions about how accurate is accurate. From what I understand, and I haven't checked the calculations myself, the Surya Siddhanta serves its intended purpose quite well. It does have to be adjusted to fit the positions of the stars from time to time. That is, it drifts off very slowly. But it works pretty well. And to give an idea of this, I could cite some figures. I have much additional data in here that I haven't been mentioning because it would be a bit too much. But for periods, for example, the Surya Siddhanta, the modern figure for the orbital period of the moon is 27.32166 days, just to give an example. And the Sirius Vedanta is 27.322. So it differs by it differs by 0.4 in the fourth decimal place. That gives an idea. For example, the period of Venus is 224.701 days according to modern calculations. According to the Sirius Vedanta, it's 224.7, so it differs by 1 digit in the third decimal place. So, things like that. So it's not a bad system. Yeah?
You're talking about the science measuring the size of the planet. It seems like we have to have one that we actually measure and then calculate the other.
Well, the method that they use today to measure that is the following. First, you have to measure the distance of the planet. So for that, you do use parallax. For example, if you have observatories on two widely separated parts of the Earth, and you know the distance between those observatories, and then you measure the angle to the planet, and you get two sides of a triangle, and you know the side in the middle, so you calculate the distance. So using this kind of thing, you can get the distances. Then you measure the apparent diameter using a telescope. And the apparent diameter and the distance enable you to calculate the actual diameter. So that's how they do it today. So they take into account refraction. They have equations for it. That's another thing that they deal with. Yeah? Yeah. Now, this is an interesting thing, which also is an interesting thing to note. The Sirius Vedanta has figures for distances to the planets. These are somewhat different from the modern figures. And furthermore, the figures for the apparent diameters projected to the moon are different from what you would get from the modern figures. But the errors cancel out when you calculate the actual diameters, which is an interesting. To give you an illustration of how that works, suppose that I had a basketball and I told you that the basketball was at a certain distance and that at arm's length it seemed to have a certain diameter. Now from that you could calculate how big it was. But suppose the distance was wrong and the diameter was wrong. That is, suppose the figure I gave you was too close and the diameter I gave you was too big. But let's say the figure I gave you the distance was half what it should be, for the sake of argument. And the apparent diameter I gave you was twice what it should be. Well, if you then calculated the real diameter, you'd still get the right answer, because the two errors cancel. Well, the odd thing is, in the table of numbers that they have, the distances are off according to modern figures. The parent diameters are off, but if you calculate the real diameters, you get the right numbers. So that is a mystery for people to ponder as to why that might be so. But one thing I would suggest is it couldn't be accidental. At least it's highly unlikely that that would be an accident. So that's.
There's no indication of what method they use to
No, there's no indication. Yeah. According to modern ideas, you need a telescope. There are some large observatories in India that at least date back to the Middle Ages, in which there are fairly good methods for determining the angular position of a planet in the sky. That is, in what direction it's located. Essentially what it amounts to is you have a sighting point and then you have a very large curved wall. And then you sight along the the location of the planet, let's say, against that point and mark on the wall where the thing lies. And then by measuring distance along the wall, you can determine the angle of the thing in the sky. Yeah. In Delhi. Yeah, I saw the one in Delhi, actually. But this will enable you to determine the direction in the sky, but it won't help you determine, say, the diameter.
If you have the direction of the sky,
you might be able to figure distance. Diameter is still a problem, because you have to somehow see the disk, unless people had very good eyesight. But, well, you never know how they might have found out. It's not that they necessarily used the modern methods. There might be other methods. Well, a demigod might have come down and told them this is what it is. Mind you, that is what the Surya Siddhanta says, by the way. The Surya Siddhanta says this is a communication from Surya, who's the sun god. So that's the version of the Surya Siddhanta. But, well, he should know.
So let me get it right. The Surya Siddhanta was in like a standard Vedic text, and it was used. This was always used as one is on the right time, performance right way.
Yeah, traditionally that's been used. And they would make tables called panchakas, which are like ephemerides, which give you positions of planets.
These rules of Surya Siddhanta are rules for generating
ephemeri. Yeah, ephemeri. That's what they're used for. And it's a standard thing. And also it was mentioned in here that Bhaktisiddhanta Saraswati made a table of that kind, but he attached the names of Krishna to everything. So he made a Krishna-conscious panchaka, apparently. Well, the same equations can be applied. Now, it becomes a matter of controversy just how accurate things were back at the time of the beginning of Kali Yuga. Now, the problem there is that there are no recorded observations, except perhaps observations in the Vedic literatures themselves. But the earliest observations that are recognized by modern scientists were made by the Babylonians in about maybe as early as the 7th century BC. They don't go back any further than that. So when we speak of different theories about what the planets were doing many thousands of years ago, we should recognize that we don't have any observational evidence.
Well, assuming that everything is regular,
yeah, assuming that. It's a big assumption. You see, modern scientists will assume that everything was regular according to Newton's equations. But is that so? That's outside of the bounds of observation. In fact, some of the early Greek reports of eclipses of the sun are disavowed by the modern scientists, because when they compute backwards using the Newtonian equations, they find that the eclipse must have occurred on a different date. So they will say that the Greeks were lying about when the eclipses occurred. They say that. Yeah. Yeah, they actually say that Herodotus, the Greek historian, lied about the date of certain eclipses, because they can calculate backwards and find out when they really happened. And they know that it's wrong. So, no, they couldn't see why he would lie about that. They figured, well, they said Herodotus is the father of history and the father of lies. So they take refuge in that statement. You had a question? It's different with the different planets. But the errors cancel out and you get the right diameters. So that's curious. So, yeah? Well, it's very similar. And this leads to a whole area of scholarly controversy. In Galileo's time, the geocentric model that was used goes back to a Greek, an Alexandrian Greek named Ptolemy, who, let's see, when did he live? Around 200 AD or thereabouts. So, the modern scholars want to trace the Indian astronomical system, such as Sirius Odonta, from this Greek system. That's their idea. But then one should realize that the modern scholars also have a program of tracing practically everything in India back to the Greeks. I've even read in some places where they want to trace deity worship back to the Greeks, of all things. One can argue that there may be some motives for this, because in the West, people have adopted the Greeks as their ancestors. Of course, most people of European descent really are descended from Goths and Vandals and Celts and other interesting people who went around sacking cities and so forth. At least the northern Europeans are in that position. And these don't really constitute particularly honorable ancestors. So, what people have done is adopt the Greeks as their ancestors. So there's a tendency to try and attribute everything to the Greeks and to glorify their position. So it's a whole subject of controversy. The actual situation is that we don't have very much historical evidence telling us what went on with the ancient Greeks and their relations with India. The information is exceedingly fragmentary. In fact, I read a whole book on ancient Greek astronomy, which supposedly outlined the history of it. And what it amounts to is that we have the book by Ptolemy, which is called the Syntaxis, which is pretty complete. And we have fragmentary references by late Roman writers, people writing in, say, the 6th century AD. And these were people mainly who wrote in Latin and who obviously didn't know what they were talking about. They made all kinds of gross errors. Apart from that, there's practically no documentary evidence, just speculation. So, who knows what the real history was? But anyway, that's a whole subject to look into. Yeah?
This whole discussion, we weren't necessarily saying that the fact that there are global people that are visualizing.
Saying?
The planets are actual global. Their planets is round.
Well, as I was saying, the way I began the whole discussion was to say, on the one hand, in our modern experience, our experience of the Earth is that it's a globe. In other words, the idea of the Earth as a globe fits our experience, our gross sense perception. And in the Sirius Odonta, it says the Earth is a globe. And the same is true of the other literatures known as Jyotisha Shastra. They all say the Earth is a globe. And they all give the size of that globe. And it comes out to be the same as the size that we think of for the Earth today. As I say, about 25,000 miles around. But in addition, the Bhagavatam describes the Earth in a different way. So, the question now is, well, what do these two descriptions have to do with one another? How do you relate them? Are they both true? Is one of them true and the other false? What's going on? So I'll really get into that in detail next time. But what I was indicating here is that the idea of the Earth as a globe is not something new in Indian tradition, or for that matter, Vedic tradition. That's been discussed for many, well, in terms of what we definitely know in black and white, it's been discussed for many centuries. We would infer that it's been discussed for much longer than that also. And the other point I made was that Bhaktisiddhanta Saraswati himself taught this Jyotisha literature, which describes the Earth as a small globe. So that can be considered. So the question is, if the Earth is a small globe and the Earth also is a gigantic disk, then how is that possible? What's the proper understanding? What this Vamsidhar said was, there are apparent contradictions there, but no real contradiction. Okay, how's that? It looks like a contradiction, so what's the answer? So I'm going to discuss that. So, yeah? Well, right at the moment, we don't have what he wrote in detail about these subjects. We have a list of titles. We do have comments that he made in his Anubhasya commentary on Chaitanya Charitamrita. Now, in his purports, the verses in the Chaitanya Charitamrita, from time to time he will just cite the Surya Siddhanta or the Siddhanta Shiromani, which is another of these literatures, and so on. He just cites them along with many other things that he cites. He doesn't say anything about whether this is valid or invalid, but you assume that he wouldn't cite it if he thought it was invalid. He just cites it. We don't have his commentary if he wrote one. We looked through to see if he wrote a commentary on the Bhagavatam. We found translations of the Bhagavatam that he wrote, but no commentary. Either, if he did write a commentary, it's in some other book that is not in the Matsya collection, since our source was this Matsya collection that Shukavak has. So it would be nice to see what he said about the fifth canto, but I don't know if he wrote anything. Yeah, basically speaking, you'd say they show the same thing from a different reference point. The modern description uses the sun as the center of motion. Everything is orbiting around the sun, and the Surya Siddhanta uses the earth as the center of motion. The calculations saying where things will be as a function of time do not agree exactly, but they're pretty close to one another. Of course, modern scientists will say that the Newtonian calculations are exact and the Surya Siddhanta calculations are inaccurate. And that's probably true in terms of, the observational data. But anyway, they give essentially the same description. And one should keep in mind that you can do the Surya Siddhanta calculations with a pencil and paper. But nobody can do the calculations of Newtonian astronomy that way unless they want to sit for many, many hours doing calculations. Of course, people used to do that a couple centuries ago. But really, you need computers to do the Newtonian calculations. They're exceedingly complicated. So one can say the Surya Siddhanta is a simple system in which just by writing a few lines of calculations you can get the positions of the planets. So it's a practical system also. In fact, in South India there's a tradition in which people have memorized all the numerical data in the Surya Siddhanta and similar literatures, and by moving seashells they can do all the calculations without even writing anything down. So they just sit down and move some seashells around and they have all the information. Yeah? Well, there were two practical applications of this in ancient Vedic culture. Well, one was astrology, which was quite commonly known. The other was determining the dates of religious ceremonies of different kinds. Practically, Ekadasi, for example. That's based on the position of the moon. But there are many other things of this kind. Just for the sake of argument, I'll quote you something from the Bhagavatam just to give an idea of this. This tells about something called the Shraddha ceremony. So it says, one should perform the Shraddha ceremony on the Makara Sankranti, on the Karkata Sankranti. One should also perform it on Mesha Sankranti Day and Tula Sankranti Day, in the yoga named Vyatipata, on the day in which 3 lunar tithis are conjoined, during an eclipse of either the sun or the moon, on the 12th lunar day, and in the Shravana Nakshatra. One should, and it goes on. Actually, I can read on for another 5 minutes here of a list of different times you should perform the Shraddha ceremony. They're all astronomically determined. It all depends on whether the moon goes into a certain constellation, and all kinds of things. The use of astronomy was a standard thing in determining times of religious performances. Yeah? Pardon me? Bhagavad Gita describes karma of the individual. I don't believe the Bhagavad Gita refers explicitly to astrology. One can reconcile the basic idea behind astrology with the doctrine of karma in the following way. Krishna says that he places different souls into wombs that are appropriate based on their karma. So, this indicates that a person is born in a situation which is appropriate depending on his past karma. Now, the idea of astrology is that there are relationships between that karmic situation and the positions of planets and so on at the time of the person's birth. Now, the idea of karma could be correct even if astrology was completely wrong. But the idea of astrology is consistent with the idea of karma. If you just suppose that Krishna, through his different agencies, such as demigods and so on, is causing souls with particular karma to be placed in particular wombs so that they're born at particular times, corresponding to the different planets being in particular positions. And it's not necessarily a correct interpretation to think that the planets influence the individual fate. To give an example, consider what would happen if you observe a factory while watching a clock. You'll see that when the hands of the clock point upwards, suddenly a lot of people come pouring out of the factory. Now you could say, is it that the metal hands on this clock influenced the people so that they came out at that time? Well, not exactly. It's not that the clock hands had a strange, mysterious influence that make people come out of factories. But there's a higher organized system in which people do things at certain times, and the clock indicates the time. So similarly, the motions of the planets are an indication of organized events going on in the universe. And just as behind the factory there's the management which determines the schedule and so forth, likewise behind the universe there are the demigods who are controlling the material affairs and so on. And ultimately, beyond all of them, there's the Supreme Personality of Godhead who's directing the whole thing. So that's the idea of how something like astrology fits into philosophy of Krishna consciousness. Yeah, they're like a sophisticated clock. And an interesting point, by the way, is that the clocks we have today started as planetariums, historically. It's curious. In Europe, back in the early Middle Ages, people would build things that they called orreries. And these had hands representing the positions of all the planets, as well as the time. Then gradually they just whittled things away until you just came down to ordinary clocks. That's actually the history. So anyway, I guess we should probably end there. All glories to Srila Prabhupada.